David Smith here with another Flipped Classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic, more work with radicals. You'll recall from the last lesson I gave you 3 little rules. We developed a couple extra rules and we did some problems. So today we're just going to do more of these kinds of problems. So you remember from our previous lesson, I just multiply these two under the root sign and I would get root 10. Is 10 a perfect square? Nope, we can't get it out, so we are done. Resist the urge to put that in a calculator and give me a big long decimal. We want to keep it in root form, okay? How about this one? Now if you recall, we multiply our numbers times our numbers and our roots times our roots. So this would be 8 times root 33. What do you think? Let's do another one. So pause the video, give that one a shot. Okay, let's see how you did. Numbers times numbers, that would be 2 times 6, that's 12. 6 times 6 is 36. Are you done? No! That's a perfect square. Square root of 36 is 6. So that comes out, that becomes 12 times the 6, which is 72. Okay, let's do another. Actually, I'm going to give you one to try. 2 root 7 times 3 root 2. Pause the video. Okay, let's see how you did. 2 times 3 is 6. 7 times 2 is 14. Take a look at root 14. Perfect square? Nope, you're done. Here's another one. Pause the video, give that a shot. Okay, let's see how you did. 3 times 4 is 12. 10 times 3 is 30. Last step, is that a perfect square? Nope, leave that as it is, so 12 root 30 is our solution. Okay, let's do a few more. Pause the video, give them a try. Root 3 over root 27. Okay, let's do that. I'm going to grab the whole thing. So this becomes root of 3 over 27. And we can reduce that down. 3 over 27 is 1 over 9. Okay? Now that's going to give us something interesting. That's a perfect square. Let's see if we can do something with that. So what I did is I went backwards on the same rule that we went forwards on here. Okay? So here I had things under the root sign separately, and I put them under one big root sign, which allowed me to do a reduction in my fraction. But then I noticed that I had a 9 under my root. So now I went backwards on the rule, and I can finish this off. What do you think that's going to be? What's root 1? That's just 1. What's root 9? That's 3. So some of these problems will get you all the way down to something super simple at the end. This looked much more complicated. We got down to just 1/3. Let's try this one. Give it a shot. Okay, watch this. Root 2 over 50. Now we know 2 over 50 is the same as 1 over 25. Again, we're seeing a perfect square in the bottom, so we can do the same thing we did there. This becomes root 1 over root 25, and then 1 over, what's the bottom? 5. Pretty nice. Okay, give this one a shot. A little more complicated, but not too much. Okay, let's see how you did. Root 81 over root 144. What does that give us? Well, we know square root of 81, that's a perfect square. That's just 9. Square root of 144, another perfect square. That's just 12. Now don't forget, you need to reduce your fractions all the way down. So 9 over 12 is what? That's right, 3 over 4. Okay, let's try a few more. Slightly different kind of a problem this time. Here's the instruction. Write root 32 in form k times root 2. So they're giving you a clue as to how they want that answer to look. Let me show you how that works. Root 32. How are we going to get there? Well, we could figure out what 32 is in terms of some factors. So how can I multiply to 32? I'm going to pick one that's really good for that. 2 times 16. That's 32. All I did is I factored my 32, wrote it as 2 times 16. Now, I picked 2 times 16 for a reason. Tell me, pause the video, see if you can figure that out. If you decided that it's because 16 is a perfect square, you're right. I could factor this into 4 times 8, but that doesn't give me any perfect, well, it gives me a perfect square, but I'm going to go this route. Now what we can do is we can go 2 times root 16, because remember we're going backwards on that multiplying rule. I can break it up into 2 roots. Now I know 16 is just 4, so I can write root 2 times 4, which we typically write this way. The constant outside of the root comes first, then our root. So check it out. We're in that form, k times root 2. So that's the idea in this process. To review, you want to look at the number under the root sign and factor it so you get some perfect squares under there. And I picked 2 times 16 because 16 is a perfect square. I broke my 2 roots up. I did my square root of 16, got my 4, and put it in the correct order. Give this one a try. Very similar, just a little different. Okay, let's see how you did. 18. That's 2 times 9. I picked this factoring because 9 is a perfect square. So that ends up being root 2 times 3, which is really just 3 root 2. Okay? Let's do this one. This one's slightly different. Pause the video, see what you get. Okay, so I need to look at factors of 98 that might give me a perfect square. And fortunately, there's a good one. 2 times 49 is 98. I picked 49 because 49 is a perfect square. 7 times 7. So the 7's going to come out, and I get 7 root 2. Okay? Let's do one more. Root 288. Oh my God, that's a ginormous number. It's actually not too bad when you see what you need to do. Pause the video. Okay, let's see how you did. What I noticed is that 288 is 2 times 144, and 144 is a perfect square. So I can write this as 2 times 144, like that. The 144, square root of that is 12, so this becomes 12 root 2. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.